Welcome back, space enthusiasts. Today, we're diving into the exciting world of space exploration to uncover the latest mission-making headlines. SLIM. What exactly is SLIM, and why is it capturing the attention of the scientific community? Let's find out. In September 7, 2023, the Japan Aerospace Exploration Agency, better known as JAXA, unveiled its groundbreaking spacecraft, SLIM. This revolutionary mission took flight from the Tanegashima spaceport, marking a significant milestone in Japan's space exploration endeavors. What sets SLIM apart is its incredibly lightweight design. At launch, SLIM weighed merely 590 kilograms, a remarkable feat considering its capabilities. To put this into perspective, it's roughly 1/7 the weight of Chandrayaan-3, the Indian spacecraft that weighed a hefty 3,900 kilograms during its launch. Accompanying SLIM on its cosmic journey was the Next Generation X-ray Space Telescope, XRISM. Both were propelled into space aboard an H-2A rocket, illustrating Japan's strategic planning for this joint mission. In a remarkable maneuver on December 25th, SLIM entered an elliptical orbit around the Moon. This orbit is elliptical, with an apogee of 4,000 kilometers, its farthest point, and a perigee of 600 kilometers, its closest point, above the lunar surface. What is fascinating is the timing of SLIM's launch. JAXA's mission occurred just 2 weeks after the successful surface component of India's Chandrayaan-3 mission and Russia's Luna 25 spacecraft's unfortunate failure. This is not Japan's first lunar rodeo this year. Earlier, the Hakuto RM-1 lander, developed by Japanese company iSpace, encountered a setback when it crashed during its attempted soft landing in late April due to engine shutdown issues. SLIM's incredible lightweight design was not just about shedding kilograms, it was about carrying significantly less fuel compared to missions like Chandrayaan-3. The propulsion module alone on Chandrayaan-3 weighed a whopping 2.1 tons, a considerable chunk of its overall weight. Chandrayaan-3 took a swift journey to the Moon, launched on July 14th, and reaching our lunar neighbor in less than a month. How? It followed a path known as the Hohmann Transfer Orbit, a speedy route facilitated by its substantial fuel reserves. On the flip side, SLIM's journey was a testament to fuel efficiency. It took a longer route, relying on a concept called weak stability boundary theory. After orbiting the Earth, SLIM swung around our planet multiple times, and gradually accumulating kinetic energy with each swing. As SLIM gained enough speed, it made its move towards the Moon's orbit, but here is where it diverged from Chandrayaan-3's path. Instead of slowing down near the Moon to be captured by its gravity, SLIM embraced a daring maneuver. When SLIM approached the Moon, rather than slowing down for capture, it allowed itself to be deflected by the combined gravitational forces of both Earth and the Moon. This deflection maneuver, calculated by physicists back in the late 1980s during another JAXA mission called HITN, propelled SLIM deeper into space. SLIM was subsequently on a larger, loopier path that was designed to bring it back near the Moon in December after it had slowed down further. This event happened on Christmas Day, followed by orbital capture the next day. By sacrificing some time, SLIM could be more fuel efficient. All this said, SLIM's standout feature is its reputation as the Moon Sniper, a title derived from what it will do on the Moon on January 19. It will try to land within 100 meters of its chosen landing site. This is an unusually tight limit given the history of moon landing missions. For example, the Vikram lander of Chandrayaan-3 was designed to descend in an elliptical area that was 4 kilometers long downrange and 2.5 kilometers wide crossrange, and it eventually landed at a spot 350 meters away from a predetermined one. NASA's hulking Curiosity rover was tasked with landing at the center of a 20 kilometers by 7 kilometers ellipse in Gale Crater on Mars on August 6, 2012, and it landed 2.4 kilometers away. The most precise moon landing in history was China's Chang'e 3 spacecraft. It landed 89 meters away from its chosen spot in the Mare Imbrium plain on the Moon on December 14, 2013. However, it was still allowed to land anywhere inside an ellipse of 6 kilometers by 6 kilometers. SLIM, in effect, will set the record on January 19 for attempting to soft land with the smallest ever area tolerance on the Moon. The chosen site is near the Scioli crater at 13.30 s and 25.20 e. Just as the Vikram lander of the Chandrayaan-3 mission used data from the Chandrayaan-2 orbiter to help guide its descent, SLIM will use data from JAXA's Selene orbiter, which ended in 2009. Its lower mass, only 120 kilograms excluding fuel, will help in this endeavor by rendering it more maneuverable, while its small size will be a test of its economical design. Just before it lands, SLIM will deploy 2 small rovers called Lunar Excursion Vehicle, LE-1 and 2. LEV-1, LEV-2, and SLIM will together study the lunar surface near the landing point, collect temperature and radiation readings, and attempt to study the Moon's mantle. Scientists are interested in the Moon's South Pole region at large because parts of some of the craters here are always in shadow, allowing the temperature there to drop very low, as well as sparing them the effects of sunlight and diurnal temperature variations. We already know these parts contain water ice, and a lunar surface mission could potentially explore these sites and attempt to extract water. When the Indian Space Research Organization successfully executed its Chandrayaan-3 mission by soft landing a robotic craft on the Moon's surface on August 23rd, it also concluded the second phase of its lunar exploration program. The first mission of its third phase is the Lunar Polar Exploration (LUPEX) mission, aka Chandrayaan-4. LUPEX will be an Indian-Japan joint enterprise. However, while JAXA has approved LUPEX, India is yet to, with an earliest launch date in 2026. It will explore an area closer to the Moon's south pole than Chandrayaan-3 did, and this makes all the difference. The terrain near either of the Moon's poles is rocky, pocked with several craters, and full of steep slopes. Axiomatically, if there is a suitable landing spot for a relatively large landing module or rover, its downrange and cross-range limits will be lower than they were for Chandrayaan-3. The craft will have to land as close to the site as possible, if not at the site itself. The technologies JAXA will test with SLIM, but especially a feature-matching algorithm and navigation systems, will be crucial for this aspect of LUPEX. For now, JAXA is expected to provide the launch vehicle and the lunar rover, while India will provide the lander module. The landing site is yet to be fixed. To compare, the Vikram lander landed 600 kilometers from the South Pole.